Work with the law of sines and cosines. We're going to look at just a few application problems. Here are a few reminders with application problems. The reminders are that when you're asked to deal with angle of elevation, elevation always comes from a horizontal line and goes up towards the line of sight. So if you're observing maybe a balloon up in the air, then the angle of elevation is here, going towards the line of sight. Angle of depression also goes from a horizontal line, but depression would be looking down. Maybe an observer on a cliff looking down to a boat. So the angle of depression is going down here from the horizontal line. So your angle of elevation and depression, they always have to be part of a horizontal line. Directional, if I want to do an angle northeast, you do a north line and then go east of that. So this would be northeast. Northwest, you do a north line and then take your other part of the angle west. This would be northwest. And then you can do the same for southeast and southwest. So I'll just do one of those two. So south and then east would be this direction, southeast. So those are considered to be directional angles. And finally, we've got radial measures. And radial measures start at the 90-degree mark, which actually this is going to be 0 degrees. And it rotates clockwise in this direction. So here's an example of radial degrees would be 060 degrees. They use 3 decimal places, 3 place values in order to represent the angle. So if I go all the way around, then this would be 180 radial, 270 radial, and all the way to this location, let's say, this would be 0, from 0 all the way to 300, so 300 radial. But the radial measures, you start from this north line. Start there and go clockwise, that many degrees. A port is 50 miles due north of Lighthouse A. A port, 50 miles due north. This is a port, Lighthouse A. A ship is 30 miles at a bearing of northeast 37 degrees from the lighthouse. All right, so since this is directly north and we've got a ship northeast 37 degrees east of north, there's the ship, and that would be northeast here 37 degrees. The port was 50 miles. We can make a triangular plot here. We got the lighthouse, the port, and the ship. What we don't know is we do not know any of the other angles. We know the 50. We also know that the ship is 30 miles from the lighthouse, so we know the side angle side here. How far is the ship from the port? So what we need to find is x. Well, we can use the law of cosines to do that. You do x squared equals the other two sides, 30 squared plus 50 squared minus 2 times 30 times 50 times cosine of the 37 degrees. And you can type all of that into your calculator. We would eventually get that x squared is equal, and go ahead and type this in and make sure that you get 1004.09. And so if you take the square root of that, you get 31.7 miles. There's your final answer. Once you draw your diagram, you can either use the law of sines, cosines, depending on what information that you're given. You would have to determine which of the equations you're able to use. All right, example 4. To approximate the length of a lake, a surveyor starts at one end of the lake and walks 240 yards. She then turns 110 degrees and walks 270 yards until she arrives at another end of the lake. Approximate how long is the lake. Well, you guys have this diagram here, so let me go ahead and get that in here. So you've got this 245. You've got this angle here of 110, the change of direction. You got the 270 yards. And basically what you're seeing here is you're seeing this circular shape, which is considered to be the lake. And we're supposed to find x, how wide the lake is. All right, well, what we know is if this is a straight path going this direction, and then the person turns 110 degrees, that's 110, we have to assume then that's where the 70 is coming from because they're a linear pair. So you know the 70 as well. Using the law of cosines, we're going to go ahead and find x. So you start with x squared equals 245 squared plus 270 squared minus 2 times 245, 270, cosine of the included angle of 70. So calculating this, again, degree mode, x squared would equal 87,675.74. If you take the square root of that, 296.1 yards. That's how far across the lake would be. All right, let's take a look at example 5. The distance on a map from the airport in Miami, Florida, to the one in Nassau, Bahamas is 500 kilometers due east. All right, so we've got, let's see here. We've got Miami, and we've got the Bahamas. And it says that the Bahamas is 500 kilometers due east. All right, Bangor, Maine is northeast of both cities. Its airport is 2,350 kilometers from Miami and 200 kilometers from Nassau. What bearing would a plane need to take to fly from Nassau to Bangor? All right, it says it's northeast of both airports. So we're going to go and do northeast of both of them, going to the right. And this is going to be Bangor, Maine. Call it Maine. And the distance here from the Miami is 2,350. And the distance here from the Bahamas was 2,000. So what we know is we know all three sides. Now the question is, what is the bearing? What bearing would a plane need to fly to go from Nassau to Bangor? So what we need to do is we need to figure out what this angle is. The bearing from here to Maine, from the Bahamas to Maine. Well, the bearing would be like 0, so many degrees, like a radial measure. So this is the north line. And obviously it's northeast, so we're going to have to find this angle here. Other things that we know about this diagram. This is a right angle. And so if I find angle here down at the Bahamas, if I find this full angle down here, then I could subtract 90 from it, and that would give me the leftover, the one on the northeast portion. So let's do that. It would be 2,350 squared equals 500 squared plus 2,000 squared minus 2 times 500 times 2,000 cosine of the angle that we're trying to find. We're going to call it angle B for Bahamas. All right, we've got to square the values, so 5522500 when you square it, 500 squared, and 2000 squared. This is taking the 500 squared and adding the 2000 squared. That's the 4,250,000. And then it's minus 2 times 5 times 2000, and that would be see how many zeros here. 1, 2, 3, 4, 5, 6 zeros. And cosine of B. All right, so just check your calculations there. We're going to subtract the 4,250,000, and we would have left 1,272,500 equals 2 million cosine of B. Divide and this would be negative. When you divide, you get negative 0.63625 equals cosine of B. So B would equal, if you do the inverse cosine, 129.51 degrees. All right, so what we can do is then, that's the angle right in here that we're trying to find, the large angle. So if I subtract 90 from that, then we're looking at an angle of 39.51 degrees, and it's east of north. There's one way that you can represent it, or you can do 39.51 degrees, and that's a radial measure. So really either one of those would work, doing a radial or a northeast directional angle. All right, let's take a look at our next problem. Area of an oblique triangle. So we have other formulas here. So here's another formula. You want to pause and maybe get this written down. This would be if you are given all 3 sides of a triangle and you need to find the area of it. S is semi-perimeter. Semi-perimeter would be half the perimeter. And then you substitute the values in. Let's look at our last problem here. Find the area of a triangular region with the sides 50, 58, and 69. We don't even need to really do a diagram. What we need is let's find the perimeter first. Perimeter would be 50 plus 58 plus 69. Okay, so what that is going to give us is 177. So S, which is 1/2 of the perimeter, would be 88.5. So what we're going to do is we're going to use this now as our semi-perimeter. So the area is going to equal, you can look back here to our formula, you take the square root of S times S minus all 3 sides. Square root of S, which is 88.5, and then it's 88.5 minus all 3 sides of 50, and 88.5 minus 58, and 88.5 minus 69. So all underneath the square root, so the area, if you go ahead and calculate that, you would get 1,423.54, and we're in feet, so square feet. So this is just another way to find the area of a non-right triangle. All right, here are your assignments for each of these parts.